Welcome to part 3. All right, so in this last video for chapter 1, we're going to talk a little bit more about variables and measurement, refreshing some things we've already covered, and then introducing a few new ideas. Previously mentioned, in your textbook describes and provides multiple examples of the notion that variables are things we can measure that vary across individuals that once operationally defined allow us to measure such variables. So this results in scores, the kind of scores that we obtain in a research study. So we've talked about variables we can measure like age, weight, height, SAT scores, hours of sleep, and then harder variables to measure like anxiety, hunger, conscientiousness, sadness, things that aren't visible and that are a little bit harder to objectively measure. And in the last video, we talked about constructs and operational definitions. So constructs being the internal attribute or characteristic that we can't directly observe, something like intelligence or sadness or anxiety. The thing that we want to measure, but we can't observe via the naked eye. And then the operational definition for the construct, which identifies the set of operations that would be required in order to measure a behavior that reflects the construct, right? So we use the resulting measurements as both a definition and a measurement of a hypothetical construct. So we talked about how if we wanted to measure anxiety, for example, well, we have to determine or operationally define precisely how we're going to measure it. So in the case of anxiety, we'd administer a questionnaire, which essentially asks someone how anxious they are in many different ways. The most validated and highly used anxiety questionnaire is known as the State Trait Anxiety Inventory. If we wanted to assess intelligence, there are a number of intelligence scores that are well validated, intelligence questionnaires that are well validated, have been widely used. That gives us scores on tests that assess people's intelligence, either in a general sense or across specific domains like verbal intelligence, spatial intelligence, mathematical intelligence, and so on. So those tests are essentially the operational definition for the construct. Another way in which variables can be distinguished is being by classified discrete or continuous. So discrete variables, such as the number of children one has, are those variables that have separate indivisible categories. So you can have 1 or 2 or 3 children, but you can't have 1.2 or 3.7 or 4.1 children. So no values can exist between two neighboring categories. A continuous variable, on the other hand, something like weight or height, has an infinite number of possible values between any two observed values. So it's continuous in the sense that the score could lie anywhere along the continuum. We can think of every interval being divisible into an infinite number of equal parts, right? So we could only have 1 or 2 or 3 children, but we could be 150 pounds, we could be 150.157 pounds, or 150.836 pounds. The interval itself is divisible into an infinite number of equal parts. So for continuous variables, we have to think about the real limits of a given score, right, measured on a continuous number line. And the real limits separate adjacent scores by demarking a point halfway between the two scores. And I'll show you a figure in just a second that'll clear this up a little bit. So any given score is going to have two real limits. The upper real limit is going to mark the top of the interval, which is again going to be the point between that score and the score just above. And then the lower real limit is going to mark the bottom of the interval, and that's going to be the point halfway between the score below and the score in question. So let's pop to a figure here, where you can see when we're measuring weight to the nearest whole pound, 149.6 and 150.3 are assigned the value 150. So they essentially fall into the interval between 149.5 and 150.5. All right, so those 2 points mark the lower and upper real limits of 150. Okay, and there are 4 important scales of measurement, and this is probably one of the top 10 most important things you will learn in this chapter, actually in this course going forward. It's important to get a handle on this. Measurement assigns individuals or events to specific categories that indicate types of scales of measurement. So categories can simply be names, such as male or female, or employed or unemployed. They can be numerical values, such as 68 inches or 175 pounds. The complete set of all categories makes up a scale of measurement. And the relationships between the categories determine different types of scales. 4 that you need to know: nominal, ordinal, interval, and ratio. So a nominal scale involves essentially things that we can describe by name. Okay, so things like gender, male or female. Diagnosis, positive or negative. Right? Experimental or control. A nominal variable would be like comparing, I don't know, test scores from 4 different high schools in a given township or county. Those 4 different high schools would be a nominal variable, the names of the schools. So nominal equals name. Another type of scale of measurement is an ordinal scale. So in this case, the categories are organized by size or magnitude. They're essentially ranked. So a typical ordinal scale would be something like Olympic medal. Right? So you've got your gold, you've got your silver, and you've got your bronze. There's an order there. Right? What the Olympic medals don't tell us is how much of a distance or difference was there between the gold and the silver and the bronze. That we don't know. Rank in class would be another example. Someone's ranked number 1. Someone's ranked number 2. Someone's ranked number 3. What is the distance between 1 and 2, 2 and 3, 3 and 4? We don't know that. We just know the order in which they're ranked. Another example would be clothing sizes. Third type of scale of measurement is the interval scale. Okay, this is a scale in which categories are ordered, and then there's an interval between the categories that's of equal size. So temperature would be a good example. The difference between 10 degrees and 11 degrees is the same as the difference between 14 and 15 degrees. Every interval is 1 degree. IQ is an interval scale. Golf scores are interval scale. Interval and ratio scales are very similar. Interval and ratio both involve ordered categories with equal intervals between the categories. The difference being, for the ratio scale, that there's an absolute 0 point. There's the possibility of there being nothing of something, right? An absence of something. In a ratio scale, we can measure the distance from 0 to some point, right? So example of variables that would fall into the ratio scale category would be number of correct answers on a test. It could be 0. Time to complete a task. Gain in height since last year, all of which could be 0. So the only difference between interval and ratio scales is that in a ratio scale there's an absolute 0 point. In an interval scale, the 0 point is arbitrary. So yes, it can be 0 degrees, but that doesn't mean there's an absence of temperature. It's an arbitrary 0. Okay, finally we're going to close out the lectures, or the video lectures for this chapter. I just want to mention to you that statistics uses a very specific language, and if you don't speak the language that's in use by everyone else, you'll have difficulty and frustration in the course, particularly if you don't understand the symbols. Statistics uses operation notation you've already learned in high school, in algebra. Appendix A in your textbook has a math review, which you should go through if you feel it necessary. Statistics also uses some specific notation, so scores are sometimes referred to as X and Y. Whether a letter is capped or not matters. So capital N is the number of scores in a population. Small n is the number of scores in a sample. Many statistical procedures sum or add up a set of scores. So the summation sign is used quite frequently. You'll see that popping up in formulas here and there. The summation sign is followed by a symbol or equation that defines what is to be summed. Right, so summation is done after operations in parentheses, squaring and multiplication or division, but it's done before other addition or subtraction. This is important to remember. And again, this will be popping up quite frequently throughout this course as we work our way through various statistical tests, which are delineated by formulas that use many of the symbols that you should be familiar with from previous math classes, and then some that you might be potentially new to you. So make sure to pay close attention in the reading to the various symbols that you encounter.